All right. Welcome to IPPM, everyone. Can people see the slides? We have a yes. All right. Hello, Martin?
Yeah,
I see you. There we go.
Hi, Tommy. So am I not presenting the during the Loopback DEX period?
You are. I do have your slides in there.
Okay. All right. Thanks.
I'll bring that up shortly. All right. So welcome, everyone. I'm Tommy. Ian is co-chairing with me. You just saw Martin, our AD. This is the Note Well. If you have not seen it before, please do take a look. This is the kind of the terms under which you participate in the IETF. If you've been here before, you should be very familiar with this. So we are currently here in MeetEcho. We do have the Jabber, which is available in the chat section of your window. We have notes that you can also access, and we do need a note taker on the CodeMD today. And for reference, today's agenda is primarily going to be about the IOAM work, so it'd be great to have someone who's not going to be super active in presenting to be able to help take notes on that. Could we get a volunteer, please? We'll need that before we can move on. And I've already filled out the agenda on that page. Any volunteers? Put it in the chat as well. All right, we're going to need someone to help step up. Okay, Sweta, thank you so much. Very much appreciated. We can move on. All right, so we have two different meetings this week. We have a 1-hour meeting right now, and then we have a longer meeting on Friday. Today we want to go through just the IOAM topics that we have. We're going to start out with some very brief updates for some of the existing working group documents that are further along, as well as Frank will tell us about some deployment work. And then we have two long sections that we've allocated to talk about kind of particular issues that we want to get to. One being integrity of IOAM data that came up during IESG review, as well as discussing some of the attacks and concerns around loopback and direct export. And we will, as we discuss, have some thoughts from Martin there about some of the concerns he has. And we're going to actually start out with those before we get to the rest of the presentation on loopback and direct export. Okay, any bashing of that? Should we launch right in? Okie dokie. Let's start out with the V6 options update.
Okay, can you hear me?
I can.
Okay, excellent. Because the tool tells me, are you speaking? It seems we're not detecting your audio. Okay, excellent. So this is an update on the 05 version of the V6 options draft. Next slide. So the key changes are really, apart from editorial updates, I try to go and align the nomenclature between the data draft and the V6 options draft. There's one note, and that came from the implementation effort that Justin Yerman is driving right now for the Linux kernel. ESET, well, it would be helpful if we just put a note like we put in other drafts as well, that obviously the container that we encapsulate IOM in, or IOM data fields in, is restricting the size of what can be in an option type. And in the case of V6, that's 255 octets. So I think that is a note that is in there now. And the other thing is that so far the draft didn't really cover direct export. Given that direct export is progressing nicely, we also asked, or we included the need for an option type allocation for direct export. So I think those are the meaty or beefy additions to the individual draft. There's one thing that I forgot, Tommy, and sorry for that. If you flip to the next slide, I forgot to clean up the author list per your suggestion. I'm going to go and do that in the next revision. So that's really like an oversight. Sorry for that. Maybe I didn't want to go and touch this thing with a mentally 10-foot stick, but well, I'm going to go do it.
Yeah, no, that's fine. I think we got some notes from the ISG about like, hey, you're going to want to reduce this list,
yeah.
but thank you.
Yeah, we're going to go and clean that up. I think you came up with a suggestion on the mailing list on how to go and progress on that, and we're going to go do very much like what we've done with the other drafts. So with this, like, well, the edits are minor, and we're carrying along. I'm not sure whether at some point we want to go and do a last call on the document, or whether we want to go and keep it hanging for a while. Because I think we for sure need to go and get Six-Man to also go look at it, right? So like we've done in the past.
Right.
So if we can go and get the review working at some point that we're starting to re-rope in the Six-Man people, I think that would be helpful.
Okay. You mentioned some of the changes that would account for things in direct export. I don't imagine that there would be any kind of dependency there, right? As far as like
dependency in what form?
There's no like normative references over there.
Oh no.
Yeah.
No.
So
I think and the other thing that I think you were helping with, and that is again what Justin put out on the mailing list, is that we're going to go and hopefully extend the early allocation.
Yes.
So that the ongoing implementations are not really impacted.
Yep. All right. Thank you. We have Hao-Yu in the queue. Go quick.
Hi, Frank. This is Hao-Yu from FutureWeek. This note in the slides, but I remember in the draft you mentioned to use IP encapsulation to support including also IOM. But my concern is that if you use this approach, it's actually changes the original purpose of the IOM, which is used to monitor the original user flows, because now you basically put it into a tunnel and the voting behavior will be changed. So how do you address that?
Well, so, and we had that discussion before, right? The approach is that as an operator, if you do use IOM with the need of double encap here, you have to go and make sure that you engineer your network in accordance, right? So that your flows don't really start to go and follow a different path. Or it would only apply to those situations where the flows will continue to be forwarded along the same path. Otherwise, yeah, to your point, there is no benefit from using IOM in that context. If you feel like we want to go and have that as a particular kind of node or additional statement in the draft, I think we can go and add that. I think it's one of the downsides of the safe method, i.e. double encapsulation. So everything comes with a trade-off, right? Everything comes with a cost.
All right, thank you. I think we're out of time for this update. And then we want to hear a 5-minute update on the Yang document. Tianren?
Can you hear me?
Yes, we can.
Okay, thank you very much. Hello everyone, Tianren from Huawei, and this is about the Yang data model for IOM. It was recently adopted by this working group. Thanks. Next. And thanks, Drew, Richard, Mickey for the valuable comments during the adoption call. And in this version, there are several major changes based on the comments in the mailing list. Firstly, as requested, we add operational container I1 info for assistant data like unit and timestamp. This is right now empty for the augment. There was a proposed example on timestamp description, but I read the IOM data draft and I think there is no need for additional information on timestamp. We can discuss this in detail in the mailing list on this. And I plan to consider buffer occupancy next step. But I would appreciate more suggestions on specific informational data. And secondly, the previously the draft associated ACL with each profile. There was a finding that the ordered list only extend within each ACL. So if two ACEs matched, the implementation does not know which ACE in which ACL to use. To solve this, I associated ACE instead of ACL with each profile in this version. And as suggested, I've added text in the document say I1 actions must be driven by the accepted packet when the matched ACE forwarding action is accepted. There's another way, but I did not take. I did not augment ACE actions because there might be different kind of filters. ACL is just one, as Drew proposed. Flows back could be another one. I believe existing structure is more flexible. And third, I removed the action transit as suggested because right now there is no use case for the transit node configuration. And fourthly, there was a suggestion in the mailing list to support interface filter. That means, for example, the egress node, we can do the decapsulating operation on all the traffic on one or multiple interfaces. I looked into the ACL model used in this draft and found that the interface filter has already been supported. So I did not do the additional augment for the interface filter. We can still use ACL filter for the proposed use case. And that's all for the update. And next. And here is the overview.
Sorry, just one quick comment on it.
Okay, I think
we want to be able to go quick.
Presented before, so yes. We can skip to the end of the slide deck.
Okay.
To the end. Yeah, and next step, we need input for the IOM info, and we will add examples on the YAM model usage, and more comments are welcome. Thanks.
All right. Do you have any comments on this one? All right. Thank you so much. All right, Frank, do you want to come back? Give us an update.
Yeah, if I'm back. Am I?
Yeah.
Okay.
Hear you.
So this is a brief kind of heads up to IPPM on a draft that originally started in OPS-AWG. It's called IOM deployment. Next slide. So the scope of that document is to really tie all the various IOM-related documents that are out there together into something that could become, say, a BCP or the likes. So everything around data fields, Yang operations, export, the various encapsulations, so that we have one document that frames what IOM is really to an outside reader that might be a little lost in all these various documents. And we started that, if we flip to the next slide, a while ago in OPS-AWG, and created a document that basically explains IOM deployments, what are domains, what are nodes, what are the different types of IOM, with the associated references to the documents. It has a section on manageability. There is a section on security considerations that will continue to grow. It talks about why data export is useful. It has a little bit of a framing. I don't want to go and call it architecture, but how the various things fit together, like encap, decap, transit nodes, and maybe a controller to go and make sure that information is gathered. And then we have stuff like on how namespaces are used, how layering is used, and how the different modes are used, and references to the various encapsulations, so that we have this as a bit of a document that ties it all together for people that want to use IOM instead of implement IOM. And if you flip to the next slide. So we started this in OPS-AWG, but given that everything is now really centered around IPPM with regards to IOM, and I think thanks for having a dedicated IOM session even now. I love that. I think it's a natural place to go and progress that work in IPPM rather than OPS-AWG, because all the people that care are here. There is another piece that, and this document is about to expire. I need to go and put in some additional work for the security section that Sean actually was recommending. And along with his review, he also, and this is why it's also here, recommended to put in a reference, and it's there in the -12 revision of the data draft to this particular deployment document, because some of the context that we have in the data draft about, say, the security section is like, yeah, you list a couple of threats, but why does anybody care? And I think the reason why you care is in the deployment draft. So we have an informational reference there. So another piece where I believe like it belongs into IPPM, and that, from my perspective, I think at some point we want to go and make it a working group document.
Has this been, when was the last time it was discussed in OPS-AWG? And
I think that's 2 meetings back or so. I think it was sometime 2020.
Okay.
I think it wasn't the last live meeting. I need to go look it up.
Sure. And do you know, do you have a sense of kind of the sentiment there of if they think the work should be done there or here?
I think what we've gotten from those discussions is that most people that commented anyway were people that had, well, the stake in IOM and came from IPPM. So yeah, we can have that conversation formally with the chairs. But yeah, originally we did it there because it was deployment focused. Here, yeah. I think we were focused more on the spec, but maybe we can go and groom everything.
Okay. Yeah, I think it'd be good to have some discussions with ADs.
I don't mind where it lives, to be honest, but sure. Given that we have a direct relationship now with the data draft, might be useful to have it here. I think we have Rob.
Yeah, I see Rob.
Yes. So with an OPS-AWG AD hat on, it makes sense for the document to be here. I think this seems like a better home. If this is where all the IOM stuff's been discussed, then I would prefer it being here. But that's just my opinion.
All right. Thank you. Noted. All right. Sounds good. Yeah. So I guess, were you planning on revving that document again, you said, and then?
Yeah, I'm going to go rev it anyway. Okay. I'm going to go rev it very soon, probably next week. and then yeah, we can go and decide what we're going to do with it.
Sounds good. All right.
Thank you.
Great. And next, we are going to get into integrity.
All right, so this is a bit of a longer thing. So next slide. So we probably remember the discussion that happened on the mailing list. Historically, IOM has been built around the assumption that this is for a dedicated, trusted domain. And as such, there has been very little focus on ensuring that nobody's going to go and mess around with the data that IOM-capable nodes would go and put in. And well, the discussions that we had recently revealed that people might have an appetite for using IOM, otherwise the discussion wouldn't have been there, in areas where there might be concerns that nodes indeed go and fiddle around with IOM data as it's progressing through the network. So we might need an integrity solution. That is not really a simple discussion, because whatever you do to achieve that, it's going to go incur cost, right? So whenever we go and create whatever type of hashes over the fields and put these hashes in, it's not only going to consume space, but it's also going to go and incur significant operational, i.e. compute costs on a per hop basis. So I think that's something to keep in mind. But people want it, so let's see what we have as options. Next slide. So what do we go and consider as in scope for the threats that we want to go and look at for integrity protection? It's like the modification of the data fields. It's the modification of option type headers. It's injection of data fields, injection of option types headers, and even potentially like replay problems that can go and occur if somebody uses an old header with a new data packet and the likes. I think all of that, whether we have all the options, everything covered with all the options that or methods that we're going to go and talk, I think we can go and look at that in a later phase. But I think that's really what we wanted to go and have as the original scope of the document. What we're not really trying to go and tackle is any type of things that are related to the management side of things, the exporting side, or people, well, treating delay as, again, something that would change the integrity of the operation. It's not really changing the integrity of the packet, but it's changing the integrity of the delay, the operation, if you would go and put delay in, and we consider that out of scope for now. So next slide. So we have basically created a set of ideas that we came up with based on the request from the working group of what could be done. And what could be done is a set of 5 methods, and these 5 methods take a couple of assumptions. And we're not really spelling it out for every single option type for now, because we just thought like, let's go and create a set of ideas first, and then we can go and discuss. So we use the trace option type as the one that I think has, well, the biggest impact across, and it could easily be applied to E2E or direct export. If it works for trace, it will work for the other ones. If it doesn't really work for trace, it might still work for E2E, as we have it with now one of the methods, method 5, later on. The basic idea is always like, and I already said that in the very beginning about the additional load that we add. It's always like we add some signed field of a hash of the node data to the packet. So we're adding a signature over what has already been in there, and we're piggybacking on top. And all the methods will use some of that base method one way or the other. So the setup that we assume is classic NCAP, DCAP, and transit nodes. In addition to that, we'll have a validator node, which we assume is typically the DCAP node, but it's a dedicated function which verifies that the integrity of the IOM data fields is indeed met. And that validator would go and then probably post the results to some network management station. Plus, you need to have a network management station or a controller in place that handles key distribution. So all of these things need to be figured out as we would design a solution in detail, but I think that's the base setup that we assume. If you go to the next slide. So 5 methods. First one is with asymmetric keys, and they're kind of piggybacking and building on top of each other and trying to optimize the problems that we had with the earlier one. First one is with asymmetric keys. The second one is with symmetric keys. The third one is space optimized with symmetric keys. The fourth one is using post-quantum methods to go and make symmetric key management a little better and easier. And the fifth one is not applicable to everything, especially not applicable to trace, but it could be low-hanging fruit for just protecting IOM for those option types that carry immutable fields, where we're not really having any intermediate node, like a transit node, fiddle around with the traffic at all, i.e. E2E or direct export would be examples of that, where we can leverage the IP authentication header. So let's go through the methods really quick. So method 1 is that each node creates a key pair, shares the public key with the validator and the network management controller. And then what we're going to go do is we're going to go and create, or we're adding a node sign field to every single hop that we're adding node data for. And that node sign then includes a signature using the private key as well over a hash of the node data of that particular element and the earlier signature, so that we're linking signatures to each other. The starting node would start with some seed and the hash of the node data of the first node, so that we're having some anchor point. And the validator would need to go through the procedure and kind of itself in order to validate that things are in order. What this does is, depending on what we're using as a method, we're adding something like 32 bytes per hop for that particular signature, right? We can go and do the very same thing. Method 2, we flip to the next slide. We could use a very similar method with symmetric keys, just a different algorithm. But the logic would be still the same. It involves that somebody would go and distributes the secrets, the symmetric keys, to the individual nodes and the validators up front. If you do that on a per packet basis, you need a key per packet, obviously. And again, similar here, depending on the method that we're using, and we have a couple of examples mentioned, it's somewhere between 16 or 32 bytes per hop that we're adding. All of this is quite heavy. So if we go to method 3, rather than having a signature on a per hop basis added, we can have the trace signature in the header of the IOM option type. And the example here is for the trace option type. We would have a trace signature there, like the 32 bytes would be added once. And all we would do then, if we go to the next slide, on a hop-by-hop basis, is we are updating that particular trace signature with the hash of node data list, so that we're always adding on top of, or piggybacking on top of, the symmetric key, and the validator would need to go and do the exact same operation on validation and see whether he would arrive at the very same signature key in there as it was received. So quite of an operational coordination effort between the individual nodes. And it would be still required that we're sharing upfront on a per packet basis all the symmetric keys. If we want to go and use a key per packet, I think which is something that we would recommend, right? If you want to make that a little simpler, we can use methods that the guys there's other efforts in the IETF, as we all know. If we go to the next slide with method 4, we could use a method loaned from the post-quantum pre-shared key distribution. Post-quantum uses symmetric keys, and their idea is to go and rather than share all the keys up front, you come up with a local key generation service that would be able to go and create keys based on the same seed in 2 locations the same way, so that based on a particular key and the key ID, you can go and retrieve exactly what kind of key you're having, because the 2 machineries on both ends work exactly the same way. So if you flip to the next slide, it articulates that at a high level. So first thing is what you need to go and do is you need to go and exchange in a secure way the seed that both ends are going to go use, i.e. the validator and the individual node. And once you've done that, then these guys can go and use their local key generation machinery to go and create the keys locally that they want to go and use, so that the key distribution nightmare is a little bit reduced. And what you need to go and then do is you need to go and carry the key ID along with the packet, so that you're using the right symmetric key that you're supposed to use for a particular packet. So that's, I think, the way to go and at least make it operationally a little easier. The 5th method, and thanks, Tommy, for already flipping forward, is something that could be entirely attributed as an idea to Greg Mirsky. In the design team, when we discussed the integrity draft, the 0.0 version, he said, why don't we just use what we have? And well, we all appreciated that idea. As we have the IP authentication header, and the authentication header, we can go and basically tell like what method, what types of, or what range of the packet do you actually want to go and see covered. So that could obviously cover the V6 options, so we can go and include it and use it. But we can obviously only use it if no nodes in between want to go and change it between the, well, endpoints of the security association. So if we go to the next slide, then there is a little bit of a quick overview that it applies to those option types in IOEM that are immutable en route, so E2E and direct export. If we assume that in direct export, like we make sure that the secrets are indeed distributed to all the individual transit nodes that need to go and extract the information. But the DEX header itself doesn't really change, so we can use it. But for anything that would go and want to go and insert information in flight into the packet, then, well, it obviously doesn't really apply, because unless we want to go and create tunnels with every single one on the planet, which I don't think is really feasible. So it's like only applicable to those option types that are immutable, but it might be at least the starting point, and maybe we arrive at the conclusion that we are good with just protecting that particular thing. I think it all depends on the use cases that people have in mind from a priority perspective. So if we go to the last slide, I think that's the final one. It's really like along the lines of what I just said. I think we need to go and understand what concerns people have. What do we want to go and protect? To what level do we want to go and protect it? What burden do we want to go and take on? Does it really need to go and cover all option types? Is it okay to go and maybe just carry a subsection of a subset of the option types? I'm also interested in seeing whether we can go and get more help on this overall thing, because this is by no means trivial. Thank you.
Thank you. All right, we have Martin in queue.
Hi, Frank. Thanks for writing this draft on short notice. It's very thoroughly thought through. I was wondering why you didn't have a variant of option 3 that used asymmetric keys. I mean, it's obviously part of the truth table. It's one of the permutations of all the sort of the variables you have. Was there some reason you ruled that out, or what?
I think I didn't really fully catch you. So you wanted a variant of which option? Sorry.
So you have the one signature per hop version, and there's an asymmetric version and a symmetric version. But when you have a single signature for the entire path, cumulative signature, you only have a symmetric keying option. And I wondered if that was just an oversight or there was some consciousness behind that choice.
No, we can add that as another method if you want to. Do you believe we should go and add that?
I honestly haven't. I don't have a real strong opinion about which way we should go. Let me rephrase that. So I do not see any advantages to having all the additional overhead of one signature per hop, which is, maybe there's some that I don't see. And my follow-up question is going to be, can you articulate, actually, should the draft discuss more pros and cons, or is it just a matter of overhead? But if my instincts are correct and there's no point in having a one signature per hop thing, then I would like to have the asymmetric symmetric discussion. I'd like to eliminate those options and have the symmetric asymmetric discussion second in the context of the single signature.
Yeah, so I think definitely we can add that option. And I would also agree that more of a discussion of the various approaches and also how well they apply to the set of requirements that we laid out at the very beginning. I think all of this could be done. But to your earlier point, it's been put together relatively quickly based on your request and Tommy's request, so that we at least have something to go and start a discussion with. So more work, yes, needs to happen.
All right, Paul?
Yeah, so the concern I have that this proposal will introduce more overhead to the IOM, which is already very large. And also, we all know that this kind of security protection is compute intensive, which will add a lot more processing requirement to the fast pass. So, so in my opinion, why not just if there's no such requirement, you use this IOM trace option. But on the other hand, in case we do need some protections, we'll find the direct export mode or the hybrid two pass method. Both are immune to this kind of attack because they will send the data independently, and which can afford the slow pass processing. So in that case, it's easy to apply this kind of protection.
Okay, thank you. If any other comments, people's thoughts on which directions they prefer?
Sorry, I'll just jump. There's no queue, so I'll just save time. So I'm sorry, Frank. In my giant cloud of comments and questions, there's actually something I would like to get your opinion on. So, do you see any advantages in the per hop signature, like the options 1 and 2, and with the additional? I mean, obviously the overhead cost is a drawback. Is there some reason that you would advocate that we keep those in play?
Do you have thoughts, Frank?
Not from me, no. I think we put this together in an iterative way, as you say, right? Where we try to go and say, well, first one really rough, then a little bit more optimized, further optimized. So I personally don't see one, but maybe somebody else sees one. I don't know. So we just wanted to go and put everything on the table.
Makes sense. So just jumping in, queue myself. Looking through these, yeah, it seems that 1 and 2, they're not practical given the overhead. I have some concerns about 4, given just kind of the it has a higher level of cryptographic complexity going on. It just kind of, it seems like it raises the bar for the work, and would be using things that would need a lot more review to push out there. And using IPsec AH, I think does have some significant drawbacks that you bring up already, of not being able to be applicable to everything. I wonder, though, to what degree can we use, essentially try to riff off of option 3 and kind of learn things from AH, consider a variant that is asymmetric key. It seems like the main issue with option 3 was just that you wanted to have a new key per packet going through. What's the primary reason there?
Well, if you want to go and protect on a per packet basis, you need to protect on a per packet basis, right? We can go and relax.
So where I guess maybe I'm missing your assumptions. Where do we need the per a separate validator per packet, as opposed to having the ability for one validator to validate all packets on the path?
Yeah, so we can relax that, as I said, right? So if there's this less of a concern, we can say we're using the same key for a period of time instead of, or a set of packets instead of on a per packet basis, so that we are removing a little bit of the nightmare to go and distribute, well, millions of keys.
Yeah, that doesn't. Yeah, that's not
right?
Practical to distribute like that.
But I think
Greg,
this is goodness, because I think what we try to go and do is we're trying to go and get some sense of direction here. And that's exactly, I think, the discussion that we were hoping for, that people say, well, yeah, well, look more into this one, and we're happy to go and relax some of our thinking and saying, well, we don't need to be that stringent that we want to go and verify that every single packet is treated by itself, but we're grouping things up into maybe do it for 1,000 packets or 100,000 packets, or rekey every 10 minutes or whatever, and then
and
work accordingly.
Right. So I guess my suggestion would be, let's go off of option 3. Thinking of the fact that we're bringing AH into this. When you're doing IPsec, ESP, or AH essays, you have a symmetric key that you've negotiated that you use for a set of packets, and then you rekey after a period of time.
Mm-hmm.
So even if we're not technically using AH, if that was good enough for that solution, why not kind of use that cadence of keying? All right. Greg is in the queue as well. Do you want to speak up?
Actually, it's a very good point about their computational impact. And that reminds me of what we have found in BFD, which support authentication mode, but in authentication mode, then each and every packet is authenticated. So what we discovered is that it's very challenging, especially in a high rate monitoring, like sub 100 milliseconds interval. And what's more efficient is to have an optional authentication, which can be requested. So the rate of the authentication would be operator choice, but being able to indicate that in this particular transaction, in this particular packet, the IAM data has to be authenticated or encrypted, I think that might be a good direction.
Yeah, that sounds like a useful knob to have. I do think there seems to be, a couple of different dimensions here, though. Does every packet have an integrity signature on it? And then separately, are you reusing keys for that domain for a period of time, or does each packet that's integrity protected also need a separate key? Which that seems like a undue burden, even if we decided to protect every single packet. Okay. So Frank, do you have useful things to kind of take another step through this? I mean, we'll need more list discussion, I'm sure, but
yeah. So should we already narrow down to just method 3 as per what you're suggesting, or do you want to go and keep that, and we would just go and remove the per hop overhead thing from 1 and 2,
I think
and then expand a little bit on, well, we could go and play around with how often we would rekey, and then add also a method like what Greg was saying, 1 out of n, and whatever, so that I think there's all kind of dovetails with what Martin was saying as well.
Yes.
That we want to have more discussion on the trade-offs of the various things. So should we already narrow things down, or do we want to keep it for now? Or
let's have this next step kind of look at these flavors of option 3. So like, so there's option 3 as you presented it. There's what Martin suggested of, can we do asymmetric keys on 3, and what are the trade-offs there? You can have kind of what I was saying of, can we reuse keys for a longer period of time and then rekey, more like what IPsec does, and then also bring in what Greg was saying of, is there a marking that indicates whether or not we require a signature on a given packet?
Yeah, can be done. Is there anybody who's interested in helping with this? If somebody is interested, go and shoot me an email.
Sounds good. Thank you. All right, I think we should move on to our next topic. Yes, and Martin commented that we should probably have, the protocol should be a standard, although the current draft is informational, and I think that's appropriate for its exploratory nature. Yeah, all righty. So next, we want to talk about loopback and direct export, and actually I'd like first Martin to quickly run through some of the concerns he had. He had made some slides for this, and then we'll have a discussion that Tal can lead about.
So we'll probably need to present the draft slides on the next session, right?
Yeah, we can let the conversation bleed over as necessary. Yeah.
Okay, sure.
Yeah, I mean, I would hope to have a little discussion about what I'm presenting here, and so we'll see how that goes. All right, so just to remind people, and by the way, obviously I'm not an expert on these, so please raise your hand if I'm telling any lies here about what happens here. but loopback essentially, as within an IOM flow, the user traffic goes from encapsulating to decapsulating node, and in loopback, each one of those transit nodes sends its telemetry back to the encapsulating node in the reverse path. And then DEX is the same idea, but instead of going in encapsulating mode, it goes some other storage facility that's arbitrarily located somewhere else. Next slide. So ever since I started showing up to IPPM, there's been some grumbling about this. I know that Brian, back when he was chair, Mira, back when she was AD, and I think they're both at MapRG right now, unfortunately. But there's been a general concern that when you have one traffic packet, that you get n control packets as a result. And elsewhere in IETF, we spent a lot of time worrying about amplification, where one packet leads to gobs of packets. And there have been some things that we've added to security consideration. Kind of the drill we do here at IETF is like somebody raises concern, we add some text to security considerations, and we check it and we move on. Next slide. There we go. Okay, so I was thinking about this, and I sent something to the list a few months ago, and like the one-to-N situation is not great, but in fact there are fairly opaque corner cases that are much worse. The worst one is DEX. I'm going to cut straight to the punchline here. So I am running a domain that's n hops across, and I use DEX to export that data to my cloud provider. Next slide. And that happens to be through Tommy's domain to get to that cloud provider. And unbeknownst to me, Tommy's also running DEX. Next slide. And he's exporting to a different cloud provider that happens to be reachable from my domain. This is a completely arbitrary, as a customer, I'm picking whatever cloud provider I want. And so so each user packet in my domain generating n control packets, which in turn generates n times n control packets from Tommy's domain. And next slide. And this keep clicking until you see more. And it's not a factorial, it's just an exclamation point. But this keeps going. So a single packet creates an infinite ping pong of exponentially increasing flights of control packets. This is obviously completely unsatisfactory. Next slide. Okay, and then for loopback, it's not as bad because there's some limitations because essentially, so the problem here, which is not as severe, is that if there is a loopback going on, so you're tunneled over some other network, and the underlay network also is running loopback, then there is some that you not only have n packets being each of the n packets up to n of the packets that I'm generating in my domain generates m times n control packets in the underlay. And you can do turtles all the way down out to some sort of limit. If you have tunnels on top of tunnels on top of tunnels, this could be some sort of like a high degree polynomial. But in practice, you're talking about probably an order of n squared sort of thing in a typical very bad case. So again, not as severe because of some of the restrictions on where these control packets go, these telemetry packets. Next slide. So this, I think, if you understand the grumbles that we originally had from the one-to-n relationship, I think you should be more grumbly now. Next slide. So, again, the standard thing to do here is just add more text security considerations. I will note that this is not like a detectable situation until your traffic blows up, because you're just these completely orthogonal network architectures that are causing these problems. Rate limiting, I think, is what is in the text right now. It's not sufficient. When a single user packet creates an infinite stream of rate limited traffic, that's not satisfactory. I guess one thing we can do is change the probability bounds. If you're using DEX or something, if there are n hops and the probability of sending a DEX packet is less than 1 over n, then at least this goes to 0 over time rather than expanding infinitely. We could do something to restrict this to domain more strongly. You could run this over not overlays in the case of loopback, or you could restrict the location of the storage a little more tightly than we have. Or like the other thing is to really, go rethink what we're doing here. These concerns have already existed. Certainly in the current case, I wouldn't approve this as an AD. Maybe we can massage this, but really, what are we doing here? Is this a good mechanism to use, or do we really need to really go back to the drawing board on this whole idea? I mean, I would hate for the group to spend a lot of time working on this and just never really come up with something that's acceptable. And at this point, I'm not convinced it's an AD, but I would like to have people maybe come out of their silos a little bit and comment on this overall problem, because it's bad, and it's worse than we thought, and maybe it's even worse than I think. So we have 5 minutes, so I'm going to shut up now and let people talk.
All right, Greg.
Martin, thank you for analysis and presenting it in so clear visual things, again, picture is worth 1,000 words. If you have a concern about direct export traversing through another domain, my understanding, and that's my understanding, I'm not an author of this proposal, that in direct export, it uses some transport which is not marked as IAM data. So it should not have IAM marking, and in my understanding of the proposal, a direct export should not trigger their cascading effect. So it's just like UDP. It could be some transport, maybe even use well-known port or use some other encapsulation, but definitely not to be IAM marked and not collect IAM data on the way to their data lake.
So I think in my model here, my traffic going through Tommy's domain is just user traffic as far as Tommy's concerned. So it would be marked at encapsulating. It would modify the encapsulating node to be IOM data, but I'll let someone more knowledgeable answer that question.
Yeah.
Further.
Okay. Thank you.
All right, Tal.
So, thanks, Martin, for raising this issue. So first of all, I agree with the importance of these scenarios. And we actually, in the drafts, we are already describing these scenarios very briefly. But at this point, like you're saying, we still need to think about suggestions for how to solve them. And actually, I think the situation is a bit worse than what you're describing it, because actually it's not limited just to direct exporting. If you think back about what we're starting from, we're not inventing exporting, right? Exporting is something that already exists in other protocols, exists in IPFix. PSAMP is a working group that 10 years ago defined how packet sampling can work. And they already described some of these threats, and they didn't resolve them. And IPFix actually also defines flow selection, but doesn't necessarily solve these problems. So I think if we're trying to solve these problems, we may need to think of a bit of a bigger scope, not necessarily limited to IPPM, because the same problem actually exists for other contexts in which you're doing exporting to an external entity.
Thank you for that context. I'm only aware of the draft that I'm responsible for as AD. So yeah, maybe there's some other broken things in IETF for sure. So whatever we could do to figure out this problem would be good.
One question, I guess, for Martin and also for Tal. Do we think it would be possible to solve this just by saying, we can batch kind of the exporting, to say, I don't know to what degree the use cases for direct exporting require that export to happen in near real time on a per packet basis, but a lot of the amplification goes away if you essentially have a digest of here's the stuff I need to export, but I only send it once I have 100 things to export, or at some cadence, and then you essentially never blow up. It's always just, I only export what I received over this time period or something. And then it's a deterministic number of times you send something. Would that be acceptable to both kind of people who want to use this as well as the people who are seeing problems? We can also think about it. Yes, and Miria is commenting that with IPFix, you do time-based exports or at the end of the flow.
Yeah, well, there's a couple of drafts that define various methods of doing sampling. They may be based on time, based on one event packets, and also based on hash. And once you're doing hash-based sampling, you get back to the same problem where you may have a malicious entity which manipulates the hash in a way that causes all the packets to be sampled.
Right. That would be a weakness of just hash sampling. Certainly.
That's an example, but probably we can find other ways to do that.
Yeah, I'd like to comment that usually we will never allow all the traffic to be, to trigger this DX data collection. We usually need to have some kind of ACL to filter the only subset of traffic. So if we are careful, right, we can avoid to resample the actual export data packet. So then we can avoid such kind of problem. But this is one possible way to handle that.
Yeah, I think, although to Martin's point, it needs to be very explicit, and coordination within one domain may not be sufficient. I think you need some deterministic bounds on how often you're sending something that's not going to be directly related to the packets coming in. All right, we are pretty much out of time. We will spill over the conversation. Frank, you were in queue. Did you want to just have one last word, and then we will talk again on Friday?
Yeah, that sounds good. I just wanted to go see whether there's a recommendation, because Martin said, should we fundamentally rethink, or should we go and try to go and massage the security considerations, which is, I think, what we're leaning towards, right? That we're saying, okay, do it in a single domain only, do it at a regular cadence, do it in an aggregated way. I think we can go and put all these things in that have been put in other places like PSAMP or IPFix, and just refer to these earlier methods. Do we want to go down that way? I have a lot of sympathy because people use it that way right now, right? Rather than saying, out of all these IOEM options, I think it's the easiest one to implement in hardware. And so if we just go and remove it off the table for now, just because of that particular concern, I think we're doing ourselves a disservice.
Right. I mean, it does seem that the technical wire encoding of the option, that part probably seems fine. It's what we need to think really hard about is what we're actually doing in response to receiving the option and putting guardrails there. All right. I think we're out of time. Greg, can you send your thoughts to the chat or the list, and then we will group back again on Friday?
Actually, to the list is a good idea. Thank you.
Okay, thank you. All right. Thanks, everyone, for your time. Have a good rest of your IETF week. See you Friday.